Okay, friends, up to this point in math, we have just been practicing our multiplication facts. You know, like 2 times 2 is 4. 3 times 2 is 6. Okay, so we're going to use that knowledge that we already have to help us with math word problems. So we're going to have to read the problem and then solve it. Multiplication problems. All right. Let me switch the color so it's easier to see on the video. There we go. Okay. So I'm going to hand out the paper. Let me make sure I give you the right one because I have Noah and Connor's dated. Okay, this is the right one. I want you to get your name, mailbox number, today's date on there. Nope.
Just put our name anywhere.
Yep, anywhere on the top. Name, mailbox number, date. Okay, let's take a look at this paper. So the directions say read and answer each question. Okay, we can do that. The next part says Andrew is having his friends over for game night, so he decided to prepare snacks and games. Look at the first one. Everybody looking at one?
Mm-hmm.
Okay. Read that with me. He started by making mini sandwiches. If he has 4 friends coming over and he made 3 sandwiches for each one of them, how many sandwiches did he make? Now, the great thing about word problems like this that have small numbers is we can draw equal groups. We could draw an array, or we could write the repeated addition, or even the multiplication fact, because we've learned all those different ways. So, thinking about this, he has how many friends coming over?
4.
Circle that. That's an important piece of information in this problem. What else is important to know in this problem? He has 4 friends coming over. There's something else we need to know. What's important? Raylin. How many sandwiches he made for each one of them. And how many does he make for each one of them? 3. Should we circle that? What is the question asking us at the very end? How many sandwiches did he make? So did he only make 4 sandwiches? No. How are we going to solve this problem? How many friends does he have again?
4.
So how many equal groups do we have?
4.
We have 4. Oh, that's hard to see. Hold on. We'll go there. Okay. So here's one friend. Here's his second friend. Third friend. Is that all? 3 friends?
No.
No. What did we just say?
4.
4 friends. Okay, so 4 friends. How many sandwiches does each friend get? What did he say he was making for each one of them?
3.
Okay, how are you going to show that then?
You're drawing 3 dots.
Okay. Do you have your equal groups created? Hands on your hips when you do. Okay, leave your hands on your hips. Looking up here, we have how many equal groups?
4.
4 groups of 3. Do you remember how we would write our multiplication fact for that? 4 groups of 3. I'll say that again. 4 groups of 3. Because what does groups of mean we're doing? So 4 what? Times, which means groups of 3. What's that multiplication equation going to look like then, everybody?
4 times 3.
Equals something, right? So where you have space, do you have space off to the right side of that? Let's write that multiplication equation. What are we writing though? I forgot.
4 times 3 equals.
Okay, and then we're gonna think about this. Skip counting by 3s. Still a little tricky for some of us? That's fine. Can you figure out what 3 plus 3 is?
6.
What's 3 plus 3 again?
6.
Am I done?
No.
Now what do I need to do?
Add the 6.
Oh, so think about that doubles fact. 6 plus 6, what does it equal?
12.
So friends, what does 4 times 3 equal?
12.
So really, are multiplication word problems really super hard? No, not really.
That's all we have to do?
That's all. We just solved problem 1. Give yourselves a pat on the back. Say, I'm so smart,
I'm so smart.
and then kiss your brain. All right. Let's go on to problem 2. Read it with me. He also made some juice from fresh oranges. If he used 2 oranges per glass of juice, and he made 6 glasses of juice, how many oranges did he use? How many oranges per glass? 2. So there's it's like kind of like putting 2 oranges in a glass, right? As a visual for us. And how many glasses of juice did he make?
6.
Could you show me that in a drawing? Could you illustrate this one for me using equal groups somehow? You can either, no, I'll let you decide. Oh, you guys are off to a great start. How many glasses are there?
6.
There are 6 glasses, right? So that means there are 6 groups. 2, 4, 5, there's 6. All right, then how many oranges of
2.
juice
2.
basically went into each glass?
2.
So you're saying there were 2 oranges worth of juice here
Yes.
and here,
Yes.
here as well,
Yes.
in each one of them?
Yes.
Because do they have to be equal?
Yes.
Yeah, in multiplication, you have to have equal groups. I don't know about you, but I'm sure thankful that I can skip count by what number here?
2.
2s. That's easy for me. Is that easy for you?
Yes.
So let's do our, oh, hold on. Mrs. Loafing's getting in a hurry. How many equal groups do we have?
6.
6 groups of 2. What does groups of mean we're doing?
Times.
We're timesing, we're multiplying. So what would our multiplication equation look like for this particular problem? What am I going to need to write first, everybody?
6
6. I heard somebody say it. Times
2.
2. Okay. So do you have your multiplication equation written?
Yes.
6 times 2. Do you have your 6 equal groups?
Yes.
All right, let's skip count by what again?
2.
2s. Here we go. 2,
2,
4, 6, 8, 10.
12.
Oh. So how many oranges did he use?
12.
He used 12 oranges to make his orange juice. That sounds good, fresh orange juice.
12 squares. I forgot what it's called.
All right.
The answer.
Everybody finished with 2.
Yeah.
Moving on to 3. Read 3 with me. Then he started to prepare the games for his 4 friends. If each game takes 5 minutes to prepare, and he prepared a total of 5 games, how many minutes did it take for Andrew to prepare all the games? There's information in here that we don't need. They gave us extra information that has nothing to do with helping us solve the problem. So listen again, sitting up straight and tall. Turn your math brains on. Open your ears. Then he started to prepare the games for his 4 friends. If each game takes 5 minutes to prepare, and he prepared a total of 5 games, how many minutes did it take for Andrew to prepare all the games? Can you figure out what extra information we don't need, that we can omit? What do you think, Amy?
Then he started to prepare games for his 4 friends.
She is so right, because listen to the question. How many minutes, we know that, right? 5 minutes. How many minutes did it take for Andrew to prepare all the games? And how many games? 5. Do we need to know anything about his 4 friends?
No.
Let's omit that information. What does omit mean? Do you remember?
Cross out.
Cross out.
Sentence.
Just the sentence that you shared with us, exactly. Then he started to prepare the games for his 4 friends. We're omitting that. Who cares? We don't need to know how many friends he has right now. We just need to know how long it took him to prepare those games. 5 minutes, 5 games. Are those important pieces of information to know?
Yeah.
What should we do with important information that we need to know to help us solve a problem?
Circle.
Let's do that right now, friends. So you should circle 5 minutes, right? Or 5. And you should circle what other piece of information? 5 games, right? So we're talking about the 5 and the 5. We have to figure out how many minutes it took to prepare all of those games. How can you do that? How would you solve this problem? Now remember, what have we been working on, friends? Adding, subtracting, multiplying. What's been our most recent thing we've been working on? Okay, so how are you going to solve this problem. I want you to think through how you would solve this problem. Show me your thinking on your paper. Oh, you guys are doing a great job. Amazing multiplication mathematicians. Ooh, and some of you already have the multiplication equation. Man, you are getting this mastered. Woo! Phenomenal. Some of you already have the product. Holy moly. Well, shoot, why am I standing up here teaching? You guys should have to teach the lessons. You already know what you're doing. All right. Looks like you all chose to do either equal groups or an array. Okay. How many of you chose equal groups for this one? The majority. All right. So does it matter if your equal groups are circles or if they're squares or if they're triangles?
No.
Or if they're banana shaped?
No.
No, it doesn't matter, does it? Okay, so how many equal groups did you create?
5.
Because what are those equal groups representing, friends? The 5 what? The 5 games. Now the information that goes inside each of those equal groups is the minutes it took him. How many minutes did it take him to get this game ready?
25.
I'm going to be lazy. How many did it take him for this game?
5.
The next one?
5.
Oh, is it 5 all the way across?
Yeah.
Why is it 5 all the way across? Because they need to be equal. Oh. Since you're a step ahead of me, what is our multiplication equation going to be? There's 5 groups of 5. What is the multiplication equation? In 3, 2, 1.
5 times 5.
Do you agree?
Yes.
Did I do it correct?
Yes.
The pressure was on me because you guys were way smarter than me on this problem. Thankfully, I know how to skip count by 5s. Do you?
Yes.
Prove it.
5, 10, 15, 20, 25.
I'm so glad you didn't keep counting on. So 5 groups of 5 gives us a product of what?
25.
25. So it took him 25 minutes to make those 5 games for his friends. Easy peasy, right?
Yeah.
All right. Right. It's going quick. Look at problem 4. Let's read it as a class, please. Pencils down so that you're focused on what the problem is telling us.
Since it's a word problem, would we have to label 25 minutes?
We would. We'll do that with our next one. Right now I'm just making sure that you are understanding how to solve through these. We'll do a sheet similar to this tomorrow and we'll work on labeling them. But yes, you're right. Okay, problem 4. Ready to read?
Yes.
Do you know how to read?
Yes.
Okay. Andrew's 4 friends decided to bring food as well. If each of them brought 4 slices of pizza and 3 bags of chips, how many slices of pizza do they have in all? Oh man, they gave us information that we don't need to know again. They're trying to trick us. They think they're tricksters, but we're not gonna fall for it. What is the question asking us? How many slices of pizza do they have in total? What information do we not need? We can omit some of the information in here. I need to find out how many slices of pizza they have in total, which means in all, right?
Mhm.
What's the information I don't need to know? Is it, I don't need to know Andrew's 4 friends, or I don't need to know about the 3 bags of chips? How many slices of pizza do they have? What do you think it is, Lucas? We don't need the 4 friends. We do need the 4 friends and the slices of pizza. So what do we not need to know? Because the only thing they want us to solve for, and that's why they're trying to trick you, the only thing they want us to solve for is how much pizza they will need in total for all of those friends. Don't fall for their tricks. Stomp on them. All right, what do we not need to know then, Lucas?
How many bags of chips?
Let's omit that. The part where it says what?
And
3 bags of chips. Did you get rid of it?
Yes.
All right. Shove it out the door.
Yeah.
That's gone. The only thing we have left to work with is what?
How many slices of pizza?
Right, the slices of pizza. How many slices of pizza?
4.
Circle it. What else do we need to know?
Of pizza.
And how many friends he has. How many friends does he have?
4.
4. Circle it. Ooh, can you visualize this problem in your mind? Can you picture the equation mentally right now? How many friends does he have?
4.
And they each get the same amount of pizza, right? Groups of, how many pieces of pizza are they getting?
4.
Before we even start with illustrating this, let's do it backwards. Let's write the equation first. What did we just say the equation was? 4 friends get equal amounts of pizza, right? Equal groups of 4. So what is our equation, everyone?
4 times 4 equals.
Okay, now illustrate it to help you be able to solve that, because we're not quite as familiar with skip counting by 4s yet, are we? You guys are good. Definitely wise on this Wednesday.
Wise, crack one.
All right. How many equal groups did you create? 4. 1, 2, 3, 4. So those are his friends. They look amazing, don't they?
Yeah.
They're the kind of friends that everybody wants.
They need
Each friend brought how many slices of pizza with them? 4. I don't know how to cut pizza very well, do I?
You do okay. Yeah, you do okay. You don't do horrible.
Okay,
It's not the worst pizza.
so 4 friends each brought 4 slices of pizza. total. That means all together. So if we have 4 groups of 4, skip counting by 4s, what's 4 plus 4?
8.
Ah, there we go. Then let's go over to this one. 4 plus 4.
8.
Do you know what 8 plus 8 is? What?
16.
You are correct. So they have 16 what?
Pizza.
Not pizzas.
Pieces.
There we go. Pieces or slices of pizza. I don't remember what the problem said. Slices of pizza. Okay. All right, we have one problem left on this. Problem 5. You ready to read it with me?
Yeah.
Lastly, Andrew tried to compute his expenses for the game night. If he spent $9 for each game they played, and they played a total of 5 games, write an equation for how much money he spent on games that night. They have a typo. Change the D in spend to a T. For how much money he spent on games that night. Okay, what's important information we need to know? First of all, what's it asking us? How much money he spent on games that night. Look back in the problem. What is important information that we need to circle, that we need to identify and circle? Aim?
We need to identify how much money he had and how much games there were.
Okay. How much did he spend on each game?
$9.
Do we need to circle that?
Yeah.
How many games were there a total of? 5. Okay. So, how many games were there?
5.
That's our equal groups. And how much money was each game? $9. So friends, we're working backwards again because it says write an equation. So we need to do that first. What are our equal groups?
5 times 9.
Okay, so the 5 games times, because each game was $9. So our equation's going to say what? Tell me what to write.
5 times 9.
Okay, now we're talking about money, correct? So on our answer, we need to make sure that we have a dollar sign. So we have 5 games, 5 groups that cost $9 each. Show me how you would solve for the product of this. They're really making you work on this one, aren't they? Having to work with all those nines.
But this was kind of easy.
Okay, so everybody had their 5 equal groups. And then you had the 9 inside each one of those groups from what I was noticing as I was walking around. Okay? How did some of you go about solving this to try to get to the final product, the final answer at the end of our equation? What'd you do, Natalia?
So I took one of the groups of 9. Well, I took 2 groups of 9 and added those, and I got 18. And then I did that one more time. And then I added those together, and I got 6.
So like that, is that what you were explaining? Yeah. Okay.
And then I added the answer from 18 plus 18 to 9.
Okay. So friends, so we've taken care of these, right? Because now we have those 18s. So what is 18 plus 18 then?
30.
Do we have to do some regrouping?
Yeah.
Yeah, because 8 plus 8 is 16. And then 1 plus 1 plus 1?
Well, it's 3.
36, okay. So then we're not done. We still have another 9 that we have to put in there with that, don't we? Another $9. So what is 36 plus 9? Does everybody know what 6 plus 9 is, or 9 plus 6? It doesn't matter which way you add it.
Yeah.
So 9, 10, 11, 12, 13, 14, 15.
Yeah.
I needed to regroup there. And then what's 1 plus 3? Or 3 plus 1?
4.
4. So how much money?
46. 45.
40. Oh, there we go. 45. What?
$45.
$45. Okay. Now, flip your paper over.
I did it the other way around. I put it.
Turn it so that it's horizontal. So like this. So you have more room across this way. Okay? On the back of that, is everybody finished double checking their work? Okay. On the back of this, I want you to skip count by 2s. And then I want you to skip count by 3s. So 12 times. Remember how we've been practicing the 12 times? So you're going to end with 24. Here, you'll end with 36. All right, but then you're not going to be done. We're going to do 5s and 10s. Okay? Go ahead and be working on those. Is it okay if you need to, on 3s, say 3, do it that way? That's absolutely fine. It's just those counting patterns that we're becoming more and more familiar with. once you have 2s and 3s done, set your pencil down. And I'll know you at least have all of your 2s to 12 and all of your 3s to 12. If you're started on others, that's fine. But get 2s and 3s finished. Threes are looking good so far from what I've seen. Check again. 18. All right. Let's skip count. I'm gonna move these in case I don't end in that same spot, okay? So let's skip count by our 2s. 2, 4, 6, 8,
10, 12,
12,
14, 16, 18, 20, 24.
oh, what's after 20? 22, then 24. Now let's skip count by our 3s. 3,
6, 9, 12, 15, 18, 21, 24, 27, 30, 36.
oh, what's after 30?
33.
33, then 36. Okay. Did you? Uh-oh. Okay, let's move on to 5s and then 10s. Okay. Oh, you jumped clear to the end instead of filling those others in.
Are we gonna keep these and put them in our folder so we could look?
All right, let's skip count by 5s. Are we ready? You're gonna have to count a little slower because remember, my hand and my brain don't work as fast as yours. Okay? So starting with
5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60.
Oh, I spaced that just right. Okay, skip counting by tens. 10,
20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120.
Okay. Now, should we throw 11s on there?
No.
Yes, watch this, you guys. But we're gonna do it together. Okay. I'm gonna erase this so I can go back to the top. All right. So if we're skip counting by 11s, we obviously start with 11.
It'd just be one more than the 10, so we can kind of.
Okay. So think about when you count by ones. It's 1, 2, 3, 4. Okay. But what we're doing is we're doubling that same number. 11, 22. What would be next? 33, 44. Then what? 55.
66,
Next.
77,
After that.
88,
Next.
99,
Okay, here's where it changes though. Remember what 10 times 11 is?
101,
No.
111,
No. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So we jump to 110.
122.
Oh, but we have to do 11, sorry. Hold on. Okay, so redo this.
Wait, the whole thing.
No, that would be right, 110. Sorry, I'm getting myself confused. All right, now if we add 11 onto that,
121.
121. 11 onto that,
131.
11 plus that would be 132.
Wait, 32?
Mhm. What do you think would be next? Because it follows a pattern.
100.
Look at the ones place. It goes 0, 1, 2.
3. 100.
Okay.
100.
So then look at the tens. 1, 2, 3.
143.
It's 143. Okay, but we don't need to know that one. I was just showing you that it was a pattern.
What?
It's okay. Because that would be 11 times 13. Okay. The 11s are super easy through the 9s, right?
Yeah.
It's the same digit. 1, 1, 2, 2, 3, 3, 4, 4. Okay, all the way up to the 9s. All right. So now what we're going to do, we have 5 minutes left. I'm going to have you can keep those out.
This was going to be our formidable time.
And let's get out our 11s cootie catcher.
Yay! That's gonna be so.
Okay, so 11s cootie catcher.
And then we catch it.